Okay, a cylindrical barrel with diameter of 2 feet. Got it? Collects rainwater. The water drains out through a valve not shown at the bottom. So we got water coming out here. The rate of change in the height of the water. So this height is going to go down as the water is draining out. The rate of change of the height is this. I'd probably do an amount and rate table right now because they're talking about amounts and they're talking about rates. So an amount is the height of the water, which varies with time, so I'll write h of t. The rate at which the height changes is this formula, dh dt, which is equal to negative 1 over 10 root h. Height is measured in feet, time is measured in seconds, the volume of a cylinder is this formula. Okay. Find the rate of change in the volume. So they want me to find dV dt, which means I need to be paying attention not only to the rate of change of the volume, but the volume itself. It's looking like a dread problem. Related rate. With respect to time, that's crucial, read slow, when the height is 4. So the height is not always 4, but there will be an instant when h equals 4. That's the instant we're interested in. We have our Danikus chart. We've read the problem. We've got all the rates written down. We need an equation that uses these two amounts. We have that equation. They gave it to us. Okay, important to remember the difference between variable and constant. The h is definitely variable. It is changing as time goes on. However, the radius of the column does not change. Don't let them fool you, though. They gave you a diameter of 2. Read slow and careful. So the radius is 1. So we know that this formula for volume is really pi 1 squared times h, or just pi h. So now we just need to take the derivative of this formula. So we say dV over dt is going to equal pi dH dt. The goal is to find dV dt, so we keep going. We want dV dt specifically at a height of 4. That's going to be pi. Now our dH dt is this formula. Just plug that in. Negative 1 over 10 square root of 4. Pen to work. Read the problem just to make sure. Yep, indicate units of measure. The volume, okay, the height is measured in feet. Therefore, the volume, the change in the volume is going to be feet cubed. So the change in the volume is feet cubed. The rate at which the volume is changing, time is measured in seconds. Read one last time to make sure I didn't miss anything. Find the rate of change in the volume of the water in the barrel with respect to time when the height is 4. Yep, it's all written down, looks good. Double check the points here. They gave us 2 points for that. If you got to here, they give you 1 point. And then if you got to the end with units, so you have this answer, including the units, they gave you 1 more point.